There we go. Okay, so what we're talking about in 13D is we're talking about a logarithm in base E. E is a number that you basically is the only logarithm base you're going to use in year 12. We're not going to use logarithms in base 10, we're going to use logarithms in base E. E is what we call Euler's number. It spells E-U-L-E-R, maybe you've heard of that. He's a mathematician, pronounced Euler, German. So this number is a bit like pi. It has an infinite number of decimal places. We often call them transcendental numbers. And so we're going to be talking about logarithms in base E. And so that's called a natural logarithm, or logarithm naturale. That's where the L and the N come from. And so just like logarithms in base 10 or logarithms in base A, ln of e to the x is x, and then e to the ln of x is x. So they're the two rules we're going to use to simplify all these steps here. So let's have a look at our first rule. Ln e to the x is x. So therefore, ln e to the 2.2 is 2.2. Okay, we've expressed the logarithm in a single power of e. Here, it's expressed as ln e to the power, so it simplifies to x on 4. In part C, we need to express them as the same power of e, a single power of e. So we can recognise at the top we've got e to the x, and at the bottom we've got e to the half. That's what the square root is. It's e to the half. They have the same base, so now we can express it as e to the power of the top power take the bottom power, x take a half. And now we've expressed it as a single power of e, it simplifies to x take a half. Okay, so it's those same operations, just with some new notation. E to the ln 4. Well, e to the ln x is x, so e to the ln 4 is 4. E to the 2 ln 3. We can't solve that immediately, but just like, remember our laws of logarithms. Let's just consider this part, 2 ln 3. Remember, if you have log a to the n, you can write that as n log a. So we can start with n log a and write it as log a to n. We have this power out front, this number out front, we can make that a power. So we're going to write that as e to the ln 3 squared. Okay, we're moving that power to be a power on 3. So that's e to the ln 9. Alright, and now we've expressed it in this form. E to the ln x is x, so e to the ln 9 is 9. Alright, last one, we've got the natural logarithm of e to the a times e to the b. That's ln of e to the a plus b. Okay, so the sum of the powers using the sum index rule. We've expressed it as a single power of e. It simplifies to a plus b. Alright, in part 2, it wants us to express these numbers in the form e to the power of k. So we could express it just. No, actually, we'll talk it before significant figures first. We're going to calculate the natural logarithm of 4. We're going to do that on our calculator. The natural logarithm button is pretty much smack bang in the center of your calculator. It says ln, and it's just above the opening bracket button. So we're going to type in ln 4, and I've got 1.386. Okay, ln 4 is 1.386. What this means is e to the power of 1.386 equals 4. Okay, remember e, it's just a number. It's a bit like pi. There's an infinite number of decimal places. It's about 2.72. Okay, so 2.72ish to the power of 1.386 is going to equal 4. We'll perform the same over here. ln of 216, that'll be 5.375. Okay, and so then what does that mean? It means e to the power of 5.375 equals 216. Alright, so just like with our logarithm in base 10. Then we're on to solving logarithmic equations. Here we have ln x equals 2. How do we get rid of a logarithm in base e? Alright, well let's think back to like this kind of question. If we had log of x equals 2, alright, this is a logarithm in base 10. We said the way we get rid of log is by raising 10 to the power of both sides. Okay, and this is where you've got x is 100. Alright, and so here the way we get rid of ln is by raising e to the power of both sides. So we're going to go e to the ln of x equals e squared. You can do anything as long as you do it to both sides. We're maintaining that equality because these numbers are the same. The powers are the same. That's made in the first statement. So then we have x equals e squared. And that's where you leave it. A lot of the answers when we come to year 12 are going to be just expressed in terms of e. Okay? That's what we call exact form. Because as soon as you round it, you get rid of some of the decimal places. You get rid of some of the accuracy and precision. Okay, ln x equals 3.41. Same procedure here. Let's apply e to both sides. All right, we're raising both sides, e to the power of both sides. And then we've got x here, and e to the 3.41 can remain like that. All right, otherwise we're getting rid of some of the details. Okay, and then on to question 4. Now I said when we have one of these showed out problems, what we like to do is start with the left-hand side and then manipulate it until we get the right-hand side. So that's true, but it doesn't always have to be that way. If you want, you can even start with the right-hand side and manipulate it until you get the left-hand side. The point is, as long as you demonstrate that it's true. If you want, you can even manipulate both sides and show that they're equal to one another. So I'm gonna make that later argument. I'm gonna do that. So what I'm going to talk about is this part here, 1 on 36. So let's start with the left-hand side, and let's go, well, that equals ln of 1 on 6 squared, which equals ln of 6 to the minus 2. Okay? So, and I'm going to leave it there. I could keep going, and you can see the answer. It's a fairly easy one. And then I'm going to say, and then on the right-hand side, guys, what we've got is we've got minus 2 ln 6. And we could use our log laws, our power laws, to bring that number up to be a power. So it equals ln 6 to the minus 2. And now I've demonstrated I've manipulated both sides, but I've shown that they're the same. Okay, you can get them to be the same. And so therefore the left-hand side equals the right-hand side. And so we've demonstrated that's true. Okay, that's all. So D is a bit of an invitation. You can have a bit of a go at it. I do recommend it. It's good preparation. And if you finish it, I do have some more challenging stuff that is around it. So, cool. Let's proceed.